Okay, good morning class, right? So today we continue to discuss for paper 2, right? So before that, okay, so for trial from another state, I already got a few of them, okay? So what I will do is for paper 1, I will put it in the quizzes so you can answer it, okay? And then for paper 2, I think we will discuss, okay? But I will give you the soft copy first, right? So maybe we'll start next week, okay? So I have to prepare a few things first, okay? Before I can give you the trial paper, okay? Right, so continue, okay? Okay, so I think this is the last slide we stopped last week, I think, okay? So for slide number 1, right? So diagram 5.3 shows an instrument used to measure the speed of air. Okay. So in diagram 5.3, okay, the levels of the color water in the U tube are same before air flows. Okay. So number 1, complete the sentence below. Okay. So when air flows, okay, at the speed of air at point A, okay. So here, okay, so here the velocity here because the air is not flowing yet, so means the pressure is same, okay. So when the air starts to flow, okay, so this one the velocity, the A will be, the velocity should be high, okay. So the pressure here should be low, okay. And here the velocity is low, okay, and the pressure will be high. Okay, so when air flows, the speed of air at point A is higher, okay, than point B. Okay, and then the pressure of point A is lower than pressure at point B. Okay, so this one is a Bernoulli. Okay, and then next slide. Okay, for the next slide, you have to mark the levels. Okay, so here because the velocity is high, the pressure is low. Okay, so when the pressure is low means the water, okay, so the water can rise up. Okay, because this one is pressure is low, so the pressure is pressure that push the water is low, so means the water can rise up here. Okay, and this one because the pressure is high. Okay, so pressure is high, so it will push down. So the water cannot rise up. Okay, so this is the level of the water, okay, after the air flows. Okay, all right, next. Okay, in a hydraulic system as shown in the diagram 3, a force F1 of 10 Newton, okay, is used to balance a weight F2. Okay, so a principle states that pressure applied to an enclosed fluid is transmitted uniformly to every part of the fluid and to the walls of the container. Okay, so what is the principle? So this the principle is known as a Pascal's principle. Okay, so this is the answer. Alright, for the next slide, okay, compare the pressure that acts on the small piston of the hydraulic fluid with the big piston in the same fluid. Okay, so because the Pascal said the pressure that acting, okay, is transmitted equally, right, in all directions. So means the pressure is same for both piston. Okay. And then another question is, give one reason why water is not suitable to be used as hydraulic fluid. Okay, because water can easy to form the air bubble. Okay, so we don't want the air bubble. Okay, so let's say if they got the air bubble, the force that we given to the piston will be used to compress the air bubble first before it being transmitted to the output piston. Okay, so that will be a waste of force there. Okay, so it is easy to form a bubble that will decrease the output force. Okay, so this is the answer. Alright, the next one you have to write the equation that relates F1, F2, A1 and A2. Okay, so the equation is F1, okay, F1 divided by A1 is equals to F2, okay, F2 divided by A2. Okay, so this is the equation. Okay, so based on the information given, calculate the output force. Okay, so we just use this formula. Okay, so we use this formula and then we see the info given. Okay, so 10 divided by 20 is equals to F2 divided by 200. Okay, so 10 divided by 20, okay, equals to F2 divided by 200. Okay, so and then you just cross multiply, you got F2 is equals to 100 Newton. Okay, so that is the answer. Okay, and then next one, page slide 6. Okay, so as a researcher in a board manufacturing company, you are assigned to study metal characteristic used to make the board. The board is as in diagram 10. Okay, so the first question asks you to state the Archimedes principle. Okay, so Archimedes principle state that when an object is fully or partially immersed in a fluid, it will experience a buoyant force, okay, that equals to the weight of the fluid displaced. Okay, so this is the Archimedes principle. Okay, so when an object partially or wholly immersed in a fluid, so there is an upthrust force, okay, or a buoyant force, okay, that acting on the object, okay, and then the buoyant force is equals to the weight of the liquid displaced. Okay, alright, next slide. Okay, for this one is the calculation questions. Okay, so already given here, a wooden tube with sides of 30 cm floats in a tank of water with 1/3 of its volume above the surface of the water. Okay, so given you the density and ask you to calculate the upthrust acting on the block. Okay, so this one you have to use the formula rho v g. Okay, this is the buoyant force formula. Okay, for the density is already given 1000, right? But for the volume, okay, so you have to calculate the volume that immersed in the water. This one. Okay, this one. Okay, this area. Okay, you see here the sides, okay, the sides of the cube is 30 cm. So means this one is 30 cm. Okay, the side here is 30 cm. Okay, and 1/3 of its volume is above the surface area. So means this one, okay, this part is 1/3. Okay, so here should be 2/3. Okay, the volume that is under the water it should be 2/3 because 1/3 is above the surface of water. So means 2/3 must be below the water. Okay. So then you just how you want to know. Okay. So this one is 2/3. Okay. So the volume, how you want to find the volume of the cube? Okay. So the cube is a length times width times the height, right? So this is the cube. So this is the T. Okay. If cube, the length is all same, right? Okay. So if you want to find the volume here, okay. So for this one, because this one is cm, right? Okay. Change to meter first because you can see the density here. They're using meter. So 0.3 times 0.3 times 0.3. Okay. So 0.3 times 0.3 times 0.3, you will get 0.027. Okay, so 0.027. So you have to multiply by 0.027. Okay, and then multiply by 2/3. Okay, wait, I erase it first. It's not enough space. Okay, okay, so 1000. Okay, the volume here is 2/3 multiply by 0.027. Okay, because only 2 over 3 from the volume here that immersed in the liquid. Okay, so you calculate the volume for the whole cube, okay, and then you multiply by 2 over 3. Okay, and then multiply by G10 here. Okay, so just use a calculator. 1000 multiplied by 2 over 3 times 0.027, okay, times 10. So you got 180. No. Okay. I check first whether it's correct or not. 0.27 times 180. Okay, so you got 180 Newton. Okay, and then next one you have to calculate the density. So the density is density divided by mass over volume. Okay, alright. So the mass here, because you know it said the object is floating, right? So remember I said if the object is floating means the buoyant force is equals to the weight of the object. Okay. So the buoyant force is equals to the weight of the object since it said it floats. Okay. So means this is the weight. Okay. So if you want to change to mass, so you just divide by 10, right? So you got 18. Okay. So 18. Okay. And then you divide by the volume of the object. Okay. So the volume of the object we already calculated before, 0.027. Okay. So you just divide 18 divide by 0.027. Okay, so you got 666.67. 666.67. So when you calculate, you got the decimal point. So make sure you take until 2 or 3 decimal point. Okay, so this one the unit should be kg m negative 3. Okay, so this is the answer for question number 2. Okay, alright, so let's move on to the next one. Okay, so you are given 4 choices of metal P, Q, R, and S. Okay, so the table shows below shows the characteristic for the 4 metals. Okay, so the first one, the metal should be shape is a streamline. Okay, so to reduce air resistance. Okay, and then the density should be low. Okay, so it will be lighter. Okay, and then the specific heat capacity should be high. Okay, so not easy to heat up. Okay, and the strength should be high, so it will be long lasting. Okay, so for this one, I choose. Yeah, I choose ash because it's streamline shape, low density, high specific heat capacity, and also high strength. Okay, so this is the answer question for B. Alright, the next one. Okay, so the forms of water transport are purposely designed, okay, so that the upthrust force produced is greater. So explain why the captain of the ship should be careful not to overload the ship. Okay, so this one you have to remember that this is Archimedes. Okay, so Archimedes means you have to mention about the buoyant force and also weight. Okay, so if the buoyant force is bigger than the weight, okay, so the object will float upward. That. Okay, but let's say for the buoyant force is equals to the weight, it will be floating, okay, stationary, okay, above the water. Okay, but let's say if the weight is bigger than the buoyant force, okay, the object will sink. Okay, so this one, if you put a more if more load being put in the ship, okay, of course the weight will be increased. Okay, so it will keep increase, okay, until, okay, the weight will be greater than the buoyant force, so the ship will sink. So this is why the captain should be careful. Okay, so because if we put more weight, okay, then if we put more weight and the weight is greater than the buoyant force, okay, the ship will sink. Okay, Alright, for D, explain why a ship may sink, okay, when it sails from the seawater to fresh water. Okay, for this one, you have to mention the density. Okay, when you mention the density, you have to mention, you cannot say that the density is different. Okay, so how it differs? Okay, means which one is much higher? Okay, so this one, the sea water, okay, is higher. Okay, so the density of the sea water is higher. So you have to mention whether, if you compare, you have to mention which one is higher, which one is lower. You cannot just say different. So you have to mention what difference. Okay, which one is higher, which one is lower. Okay, for this one is the density of the fresh water, okay, is smaller than seawater. Okay, because this one is transfer from seawater to fresh water, right? So I use fresh water. Okay, the density of fresh water is smaller than seawater. Okay, and then you know the formula for the buoyant force is rho v g. Okay, rho is actually the density of the liquid, okay, that the object that we what liquid that we put the object. Okay, so this one is the density of the liquid. Okay, so when the density of the liquid is decreased, okay, so means the buoyant force also will be decreased. Okay, the upthrust force also will be decreased. Okay, so the buoyant force will decrease. So this, okay, will make the weight, okay, will be bigger than upthrust force or buoyant force. So then it will sink. Okay, so the density of the water is smaller than seawater. Okay, and then you refer from the formula. So the buoyant force will be decreased. Okay, and then the next one, the weight will be greater than buoyant force. Okay, so this is the answer for question D. Right, so we move on to the next one. Okay, diagram 9.1 shows a duck mother and her duckling, okay, floating in the water river. Okay, their weights are balanced by the buoyant force. Okay, so because it's floating means the weight is actually equals to the buoyant force. Okay, right. And then what is the meaning of the buoyant force? Okay, so the buoyant force is actually the upward force, okay, that acting on the object that immersed in the liquid or fluid. Okay, so this is the buoyant force, right? Okay, next one. Okay, so this one you have to compare. Okay, so using diagram 9.1, compare the weight of the duck mother and her duckling. Okay, so the weight of the duck mother is higher. Okay, and then the volume of water displaced. Okay, so the volume of the water displaced for the mother, okay, is higher. Okay, for the duck mother is higher. Okay, and then because of the weight, okay, remember that Archimedes said the weight of liquid displaced is actually equals to the buoyant force. So if you said the weight of the liquid displaced or the volume of the liquid displaced for the mother is higher, so means the buoyant force acted on the duck mother also higher. Okay, and then the next one, the higher the buoyant force, the higher the volume of water displaced. So this one, if you put the higher the buoyant force is equals to the volume of water displaced, this one is wrong. Okay, actually the buoyant force is equals to the weight of the liquid displaced, not the volume, right? And the next one is the asking you to make a deduction, okay, for the relationship of buoyant force and the weight of water displaced. Okay, so since you know that the Archimedes said that weight of the liquid displaced is equals to the weight of the object. Okay, so means the buoyant force is equals to the weight of water displaced, or you can say the higher the buoyant force, the higher the weight of water displaced also can. Okay, alright, so next one. Okay, name the physics principles involved. Okay, so this is the hot air balloon, I think. So this one should be the one is not Bernoulli. This one is Archimedes. Okay, sorry. This one is Archimedes. Archimedes. Okay. Archimedes principle, right? Alright, the next one is asking you to explain why the hot air balloon rise up when the air in the balloon is heated. Okay, so the first one, when the air balloon inside the hot balloon is heated, the density of air becomes smaller. Okay, so because when you heat the air inside the hot balloon, so the air will become hot air. So you already know the hot air is actually very light. Okay, so it means the density is become lower. Okay, inside the hot air balloon. Okay, and then the density of the surrounding is higher. Okay, so if you compare, okay, the density of air inside the hot balloon and the surrounding, the density of the hot air balloon, okay, inside the hot air balloon is lower, okay. So means the buoyant force, okay, around the hot air balloon, okay, is higher. So the buoyant force also will be increased, okay. Use the formula rho v g. Okay, and then the buoyant force is higher than the weight of the hot air balloon. Okay, and then it will push the hot air balloon going upward. Okay, since the buoyant force is greater than the weight. Okay, so this is the question for B. Okay, so you can see here. Okay, make sure you answer in the point form. So each point will be 1 mark. Okay, alright, the next one. Okay, so diagram 9.3 shows the air balloon which is used as a weather balloon to carry a radio sound, okay, instrument for collecting data about the atmosphere. So the the weather balloon rises up when it's released in the morning. Okay, so this one you have to modify. Okay, alright, the first one is the gas used in the weather balloon. So you can put helium gas, right? Because helium gas is actually very light. Or if you're not sure, right, what is the gas being used, you just can put light gas. Okay. So because if you put helium gas, okay, the answer should be lighter. Okay, or if you put light gas, so this one to increase the buoyant force, right? And then the material for the balloon, okay. So material for the balloon is strong material, so long lasting, not easy to tear off. Okay. And the second one, the third one is the waterproof material for the balloon. Okay. So must be a waterproof material. So this is not easy to tear off. Okay. And fourth is the big size of the balloon. Okay. So more gas can be filled. Okay, or you can say increase the buoyant force, right? And the last one is a strong material of the string, okay? So not easy to snap, okay? So this is the modification for the weather balloon. Alright, next one, number 3. Okay, in hydraulic system as shown in diagram 3, okay, force F1 of 10 Newton is used to balance weight of F2. Okay, so I think we already answered this one, right? Yeah, this one we already answered. High pressure, water can form bubble easily. I think it seems like this one, correct? Yeah. So this one the question is same. Okay, and then this one also we already discussed. Okay, so we move on to the next one. Okay, number 7. Diagram 7.1 shows the cross section of a wing of an aeroplane. Okay, so this name the shape shown in the diagram 7.1. So this one is called as a aerofoil. Okay, aerofoil. And then ask you to label with letter S for the region that has high velocity of air flows in diagram 7.1. So S should be here. Okay, high velocity, low pressure. This one, low velocity, high pressure. So the difference in pressure will form the uh, upward force, right? That will lift the wing of the aeroplane. Okay. Alright. Next slide. Okay, so name the physics principle. Okay, name the physics principle involved in the diagram 7.1. So of course Bernoulli. Okay, so state the principles. Okay, so when the velocity is high, the pressure is low. Or you can say when the velocity is low, the pressure is high. Okay, alright, next one. So diagram 7.2 shows a Bunsen burner. Okay, some modification need to be done to find the largest flame and complete a combustion. Okay, so based on diagram 7.2, state the suitable modification and give one reason for the modification. Okay, so the size of the whole air flow in, so should be big size here. Okay, so more air can enter the Bunsen burner. Okay. And the next one is the size of the nozzle gas flow out. Okay, so the nozzle here should be small. Okay, why? So because when the small size of nozzle gas, you will produce the high velocity of gas. Okay, so if the nozzle have the small hole, mean this one the velocity is high. So velocity high, okay, using the Bernoulli, right? When the velocity at this part is high, the pressure will be low. Okay, and then the pressure, atmospheric pressure is high. It will push the air, okay, to flows into the Bunsen burner. Okay, so oxygen means the air consists of oxygen, right? So mean the complete combustion will be occur, right? So that's the how does the Bunsen burner, okay, the working principle for the Bunsen burner. Okay, so high velocity of gas, or you can say produce low pressure of gas also can be. Okay, and the next one is the gas pressure should be high gas pressure. Okay, so this one to produce the bigger flame. Okay, alright, next one is the number 11. Okay, so number 11 state the principles involved. For this one is a Pascal. Okay, so Pascal principle. Alright, so based on diagram 11.1, explain how the spurts of water come out uniformly. Okay, so you have to say first the piston is pushed. Okay, so when the piston is pushed, mean you exerted a force to the piston. Okay, so then you will produce a pressure, right? And then this pressure will transmitted equally throughout the liquid here. Okay, so the pressure will transmitted equally through the water, and then the pressure will push the water, okay, to spurts in all direction with the same value of the pressure. Okay, because this one using Pascal, so you have to know the Pascal said the pressure is same. Okay, so you put the force, you give the force to the piston, okay, and then it will produce a pressure, and the pressure will transmitted equally throughout the liquid here. Okay, and the water will spurts out in all direction in the same, okay, magnitude of pressure. Okay, so this is the explanation from for the uh, syringe. Okay, all right, next one. Okay, for B, okay, diagram 11.2 shows a hydraulic brake, okay, system in a car. Okay, so a car needs an efficient hydraulic brake system for safety purpose. Okay, so if the brake do not function properly, it will put everyone on the road in danger. So you are required to investigate the characteristic of hydraulic brake system in a car as shown in table 11. Okay, so this is the characteristic. So you have to choose. Okay, so the characteristic of the brake fluid should be incompressible. Okay, why? Because we don't want to form the gas bubble. Okay, so gas bubble will not form. Okay, and then the material. Okay, the material we use is steel. Okay, so it's a long lasting. Okay, and then high spring constant. Okay, not easy to snap. Okay, or can withstand higher force. Okay, can withstand higher force, not easy to snap. Right, and then the ratio, okay, for the master pistons to the brake cylinder. Okay, so the master piston is here. Okay, and the brake cylinder is here. Okay, So this one should be smaller, right? Because we just want the input force will be smaller, but the output force should be bigger, right? So this is 1 over 5. Okay, so 1 over 5 because to produce a higher output force. Okay, and maybe you can add an smaller input force. Okay, so you don't need to push the brake so hard. Okay, because you only need the small input force. Okay, so this one is actually depend on the cross sectional area. Okay, so if you use, you know the formula P is equals to F over A, right? So PA is equals to F, right? So means if the area is higher, okay, the force also must be higher. Okay, so that's why we just use a small area for the master piston. So you don't need to put the high force to the brake, okay, if you want to stop the car. Okay, so that's the answer. So I choose R. Okay, so I choose R because brake liquid is incompressible. Okay, made from steel, high spring constant, and the ratio of the cross section 1 over 5. Okay. Alright, so we move on to the next question. Okay, so this is the calculation. Okay, so wait, I put hmm, okay. Alright. So for this one, diagram 11.3 shows a hydraulic jack which is used to lift up a car. So 150 Newton force is exerted on the small piston. So calculate the pressure transmitted in the hydraulic liquid. Okay. So P is equals to F over A. Okay. This is Pascal, right? So P is F over A. Okay. So the force here is 150. Okay, 150. Okay, and then the area. Okay, so you have a choice. Okay, whether you want to convert it or not. Okay, but if you want to use a Pascal, you have to convert this one to meter first. Okay, but let's say if you don't want to convert it to Pascal, okay, so you can, but the unit should be NCM negative 2. Okay, you cannot put Pascal. Okay, you have to put NCM negative 2. Okay, so I give you a choice. So let's say if I don't want to convert it. Okay, so I just put 10 here. So I got 50, 15. Okay, 15 and cm negative 2. Okay, so this is the pressure. But let's say if I want to convert it, I want to use the Pascal unit. Okay, so same formula. Force is 150. Okay, so how you want to change 10 cm negative 2? Okay, so I think last week I already teach you. Okay, so cm negative 2. Okay, so centi is 10 power of negative 2. Correct? Okay, and then here you can see the power here is negative 2. Okay, so negative 2. So you got 10 power of 4. Okay, so here, sorry. Sorry. No, 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 no. Sorry, not negative 2. Tn square, right? So this is square. So this one should be square too. So this one is 10 power of negative 4. Right? And then you just divide. Okay, so 150 divided by 150 divided by 10. Okay, so you got 150,000. Okay, 150,000 Pascal. Okay, so this is the pressure for this side. Okay, this one we use this for we calculate the pressure for the small piston. Okay, Because this one is not complete, right? It doesn't give you the Newton here, the force here, so we use this side. Okay. Okay, I check first whether it's correct or not. This one is correct. This one is 10 power of negative 2, cm negative 2, 2, so negative 4, 250 divided by 10 power of, okay, so correct. Okay, so this one, the next one is if you have to measure the weight of the car. Okay, so we already calculate, we know that the Pascal said the pressure is same, right? So let's say here, okay, if I use this value, okay, 15, okay, so 15 Newton cm negative 2 on this side should be 15 and cm negative 2 because Pascal said the pressure is same, right? Okay, so just use the formula, okay, P is 15, okay, and F you need to find, okay, the force is actually the load here, okay, and then the area is 25, okay, you don't need to change because this one you didn't change to meter, right, so you just multiply 25, multiply by 15, so you got 375 Newton, okay. This one if you didn't change the unit. So let's say if you change the unit here, okay, so let's say the pressure is 150,000, right? Okay, we use this one. And the force you need to find, okay, the area here is 25 times 10 power of negative 4, okay. Same way we just change using the same way before, okay. Okay, and then the answer should be 150,000. Okay, multiplied by 24 exponent negative 4. So you got the same answer, 375. Okay, 375 Newton. Okay, so it's up to you whether you want to change or not. Okay, but let's say the answer one in the Pascal. So let's say for paper 1, okay, the answer is in Pascal. Okay, so you have to change, okay. But let's say in the paper 2, right, you don't want to use Pascal, okay, because you feel very hard, you need to change the unit first, right, the prefix first. But you have to remember the unit you have to use NCM negative 2, okay, don't use Pascal. Okay, if you want to use Pascal, you have to change it first, okay. Right, so we move on to the next question. Okay. So diagram 5.1, okay, shows a simple mercury barometer placed at the sea level. Okay, so diagram 5.2 shows the height of the mercury column when the barometer is placed on top of Mount Ledang. Okay, so this is placed at the sea level. This one is placed at the Mount Ledang. Okay, so you have to know, okay, so the density of the air, okay, at the Mount Ledang is very low, okay, it's low. So means the pressure, the atmospheric pressure at the Mount Ledang is low. Okay, because the pressure is actually depend on the collision of the air molecule, right? So since the density of air is lower, of course means the air is the amount of air, okay, on the top of the mountain also should be lower. So this will make this will decrease the rate of the collision of the molecule. Okay, then you know that the rate of the collision of the molecule is actually that will produce the pressure. Okay, so the pressure is actually depend on the rate of the collision of the molecule. If the rate of the collision of the molecule is higher, so mean you have the higher pressure. Okay, so if the rate of the collision is lower, means the pressure will be lower. So since the density is lower, so mean the density of air is lower, so it mean the rate of collision also will be lower, and this will be lower the pressure. Okay, so that is the explanation. Okay, why the pressure at the top of the mountain is usually lower. Okay, all right. The next one you have to compare the height. Okay, so the height of the vertical column of mercury is higher at diagram 5.1. Okay, and then you have to relate the altitude with the height of the vertical column of mercury. So the higher the altitude, the lower the vertical column of mercury. Okay, and then the next one, name the physical quantity which affects the height of the vertical column of mercury. So this one is atmospheric pressure. Okay, so what is the relationship between the physical quantity in 5b1 with the height of the vertical column of mercury? Okay, so when the higher the atmospheric pressure, okay, the higher the height of the vertical column. Okay, so this is okay. Then the next question is, if a gas is filled in the vacuum column as shown in diagram 5.3, what will happen to the height of the vertical column of mercury? So before this, you know that this part is vacuum. So mean there will be no gas that exerted on the mercury column, okay, inside the tube here. Okay, so if you put the gas, okay, so means there will be a pressure of gas inside here, right? So it will push the mercury column, okay, so it push down the mercury column, okay, and so this will decrease the height of the mercury column. So because the gas pressure will push the mercury level downward. Okay, right, next one. Okay, so I guess one modification that need to be done to the barometer if the mercury is replaced with water. So explain your answer. Okay, so actually this one is depend on the density. So both of it has a different density. Okay, so for water, right? For the water density is 1000, right? Okay, but for the mercury, okay, for the mercury is for the mercury is 13,600. 13,600. Okay, so means the density of the mercury is higher, right? So next, so let's say if I use the formula H is rho, H is rho, wait, no, no. Um, wait, this first. Okay, H is actually P is equals to rho G, right? So H is equals to P rho G. Okay. So now you change the mercury to water. So means the density is decreased. Then what will happen to the H? The H will increase. Right? So means you have to increase the length of the barometer. Okay, because the density of water is lower. Okay, so you have to increase because let's say if you bring the barometer, you change the barometer from mercury to water, okay, then the H will keep increasing. Okay, so mean you have to increase the length. Okay, so that's why we have to increase the length because the density of water is lower. Okay, so this will increase the H, right? Okay, so this answer for D. Okay, and then next one, okay, we go to chapter 4. Okay, so chapter 4, diagram 4 shows a model of frying pan, okay, for cooking food, right? So what is the meaning of heat capacity? Okay, heat capacity and specific heat capacity. So what is the difference? Okay, so for heat capacity, you don't need to mention 1 kg of the substance. Okay, so the amount of heat required to increase 1 degree Celsius for substance. Okay, so this is heat capacity, right? For the specific heat capacity, the amount of heat required, okay, to increase 1 degree Celsius for 1 kg of substance. Okay, so that's the specific heat capacity. Okay, so the difference is actually they give you the exactly amount must be 1 kg of substance. Okay, so that is answer for 4A. Okay, so a mother want to cook for a food for her child, so she has to prepare the dish in a short period of time. So based on diagram 4, okay, state one characteristic of frying pan that's suitable to cook food. Okay, so the first one should be low specific heat capacity, or you can say use metal, right? I use metal also can. Okay, low specific heat capacity. And next question, suggest a way that she could do to make her food cook faster. So you can increase the heat given to the food. Okay, so it will cook faster, right? Right, next one. Okay, so this one is a calculation question. So a kettle containing 0.5 kg water is being heated. So the heat absorbed by the water is 1600 joule. So asking you to calculate the rise temperature of the water. Okay, so we try to take out what is the info given in the question. So M is 0.5. Okay, and then the heat absorbed is actually Q. Okay, Q is 1600. Okay, and then given you already C is 4200. So this one you have to use, you want to find theta, right? So theta you need to find. So use formula Q is equals to MC theta. Okay, so M is 0.5, C is 4200. Okay, theta you need to find, and Q also already given 1600. Okay, so you just divide 1600 divide by 2100. So it should be 0.76, I think. 0.76 degrees Celsius. Okay. Very small amount. Okay. Am I calculating correctly? Yes. Okay, 0.76 degrees Celsius. Okay, so based on the answer in 4C1, okay, state one assumption that you can make. So this one is mean there is no heat loss to the surrounding. So mean the heat absorbed, okay, is completely used to increase the temperature. Okay, so you don't is there is no heat loss to the surrounding. Okay, so that is the assumption. Okay, next one. So diagram 5.1 and 5.2 shows experiment to study the relationship between temperature and the pressure of gas. Okay, so temperature and the pressure of gas. Okay, so this one, the first question asks you the function of Bourdon gauge. Okay, so function of the Bourdon gauge is actually to measure the gas pressure. Okay, you have to put gas pressure. If you put pressure only, it's wrong. Okay, so to measure the gas pressure. Okay, next one. Okay, compare, right? Compare the temperature of the trapped air inside the round flask. Okay, so the pressure, the temperature for diagram 5.2 is higher. Okay, and then the reading of Bourdon gauge for diagram 5.2 also higher. Okay, and then the volume is same. Okay, this one because you know the gas law PVT, right? Okay, so this one we use volume, temperature and also pressure, right? Because Bourdon gauge is used to measure pressure. So pressure and temperature. So means B you have to constant. If you use Boyle's law, P and V, they say the experiment is investigate the relationship P and V. So means the temperature will be constant. Okay. Alright. So the next question. Okay, using your answer in 5B1 and 5B2, state the relationship between temperature of trapped air and physical quantity measured by the Bourdon gauge. Okay, so just the Bourdon gauge measure the gas pressure. So the higher the temperature of the trapped air, the higher the gas pressure. Okay, using a kinetic theory of matter, explain your answer in 5C. So maybe why you say the higher the temperature, the higher the gas pressure. Okay, so when the gas is heated, okay, when you give a heat energy to the gas, right? So the gas molecule will move faster. Okay, so when you move faster, of course the speed is increasing, right? So you know the kinetic energy formula is half mv square, right? Half mv square. So means when the velocity is higher or the speed is higher, the kinetic energy also will be increased. Okay. And when you move faster, okay, of course the rate of the collision between the gas molecule and also the wall of the container also will be higher. Okay, and I already mentioned you so many times that the pressure is actually depends on the rate of the collision of the molecule. So if the rate of the collision of molecule is higher, the pressure also must be higher. So when the gas of air molecule, okay, increase, the collision is increased, okay, between the wall container and the gas molecule, so means the pressure also will be higher. Okay, so that's the explanation. Okay, 2 marks. Okay, next one. Okay, so name the physics law. So this one is a pressure's law. Okay, pressure's law. Okay, so diagram 8.1 shows an uncalibrated mercury thermometer placed in a beaker, okay, containing ice cube and water at 0 degrees Celsius. Okay, so the length of the mercury column L is 6 cm, right? And then diagram 8.2 shows the length of mercury L 20 cm when the ice cube and the water is and the beaker are boiled until 100 degree Celsius. Okay. So diagram 8.3 shows the length of the mercury column L 16 cm when the thermometer is placed in a hot liquid with a temperature theta degrees Celsius. So we don't know what is the temperature. Okay. So A is complete the following sentence by ticking right in the correct box. So actually, working principle of thermometer is thermal equilibrium. Sorry. Right. Okay, the next one. Hmm. Okay, based on diagram 8.1 and 8.2, determine the difference in length of mercury column. So 8.1 already given, the mercury is 6 cm. Okay, 8.2 is 20 cm. Okay, so you just minus 20 minus 6, so you got 14 cm. Okay, and based on diagram 8.3 and answer in B1, calculate the temperature theta in the hot liquid. Okay, so the temperature for the the length of the mercury for the hot liquid is 16 cm. Okay, so we use the formula. Okay, L theta minus L0. Okay, L theta minus L0, L100 minus L0 multiplied by 100. Okay, so the L theta is 16. Okay, so the L0 is 6. Okay, and then this one L100 minus L0, this one is already calculated here. You got 14 cm. And then you multiply by 100. Okay, so 10 times 100 divided by 14. So the answer is 71.43 cm. Sorry, degree Celsius, not cm. 71.43 degrees Celsius. Okay, so that is the answer for B1 and B2. Okay, next one. What will happen to the boiling point of water if it's boiled on the top of the mountain? Okay, so on top of the mountain, the pressure is low. Okay, so when the pressure is low, the temperature of the boiling point also will be lower. So the answer is decrease. Okay. Alright, the next one is diagram 8.4 shows design of the thermometer which can be used to determine the temperature of the patient. Okay, so next you have to choose, right, which one is the best thermometer, okay, to measure the patient the temperature. Okay, so the first one should be the suitable range is 30 to 45. Okay, so because the normal body temperature for human is 36.5, right, we never reach until 10 degrees Celsius, right, so that's not normal. Okay, so the normal body temperature for human is 36.5, or you can say 37 degrees Celsius also can. Okay, 0 until 100 is actually we use in the lab. Okay, that one is for the lab. Okay, for human, okay, if you want to measure the body, patient's body, we just use 30 to 45. Alright, and then the next one is the diameter of the tube capillary should be small. So this one is to increase the sensitivity. Okay, means it can absorb. Okay, it's easy. Okay, for the mercury to rise up. Okay, to expand. Right. And then the next one is the choose the suitable accuracy for the thermometer. So it should be 0.1. Okay. So the answer is same. Okay. Increase the sensitivity. Okay. So then the last one is we have to choose. Okay. So use the Q. Okay. So I choose Q. And then this one you don't need to mention the reason. Only for the AC part that you need to mention, copy back all the characteristic. For this one you just put whether Q or S. Okay. Just because one mark only. Okay. So I think I stop first until here. Okay. So I see you on Friday. And before that, good luck. Okay. I know we don't have a trial. I'm not sure whether the trial will be conducted, okay, after the school open or not. But I heard that maybe your trial will be continued, okay, when the school is open on January. Okay. So I hope you still prepared, okay, still focus on your study, okay. And if you have any problem, you can discuss, okay, with the teachers, okay. And okay, please stay safe, okay. Take care yourself, okay. Don't be too stressed, okay. I know this is not normal, okay. Usually we finish your SPM on December, right? Now have to extend until March, okay. But what there's nothing we can do, okay. It's a new normal, right? Okay, so I hope all of you stay strong. Okay, don't forget. Okay, whatever happen, your SPM still you have to go through your SPM, right? So please study hard. Okay, but don't be too stressed. If you have any problem, okay, talk to your teachers. Okay, to your friends. Okay. Alright, so I guess see you on Friday. Okay, and for the trial paper, okay, I will give you in form of quiz for paper one and paper two we will discuss because sometimes okay, there's a certain topic okay that will be same as the SPM. Okay, a certain topic. Okay, so we going to discuss for paper two okay and paper three also. Okay, so I hope you still have a momentum, the same momentum. Okay, all right. So see you on Friday. Thank you, class.